Hey guys, today we're gonna go over logarithms. It's pretty simple, okay? If you're struggling with this, don't worry about it because it's pretty simple. Okay, I'm gonna give you some rules, some properties, and you're gonna learn them and you're gonna play with them to solve problems, okay? That is what we're gonna do today. First of all, what is a logarithm? It's pretty easy. Let me give you a very simple example. If you have 10 to the x power is equal to 100, how do you know how much x is? Now that might not be that hard. You probably know what this equation should look like. You know that x equals 2. But you need a more rigorous method to show that x equals 2. So what do? You use a logarithm, okay? Which is basically a convention mathematicians use to represent when they want to say what is the number, the exponent, such that a base, which is going to be 10 in this case, 10 is like the base, is what x is sitting upon, is going to be equal to 100, okay? So if we say logarithm in base 10, because 10 is the number that we have in the bottom, of 100. So if we want 10 to be equal 100, what number x should we put right there? Well, you know that if you do 10 squared, you're going to get 100. So that means that x is equal to 2, okay? This is basically asking you have a small number, which is 10. That's why you put it like in the bottom. And you want to get from this small number to this big number right there, which is 100. And the result of this operation, of this logarithm, is the exponent that you need for 10, okay? Which in this case is going to be 2. It's that simple, okay? So if I give you this example, you should be able to solve it. If we say log base 2 of 8, how much is this? This is asking you, if you have 2 and you have x as an exponent for 2, and you want to get to 8, how much is this? How much is x? Well, you know, if you do 4 times 2, that's going to give you 8. And 4 is equal to 2 squared. So if you have 2 multiplied 3 times, this is just simply going to be 3, okay? X is equal to 3. And we know the logarithm is equal to x, such that x, x as an exponent for 2 is going to give you 8, okay? It's that simple. I hope you're seeing the reasoning behind this. Now let's do another example, which is also quite simple. Log base 5 of 25. This is pretty easy, okay? How many times do you need to multiply 5 to get to 25? Well, you know you need to do that twice. And that is, you need to have 5 squared. So this logarithm is basically 2, okay? Now, if we stop using numbers and we go to variable form, if you have the following, log base a of b is equal to x, you can transform this logarithmic form into an exponential form, that is what it's called, like this. So you have a as the base to the x power is equal to b, okay? This is like a form or shape you need to memorize or learn. You don't have to memorize this, okay? It's just logic to be able to transform this into this, okay? You have a base a, and the result of the logarithm is going to be the exponent a uses. And that is going to give you b, which is the big number that you have. Okay, it's that simple. Now, logarithms have properties, and we really want to be able to use them in equations. So the first property is this one. If you have, say, log base a, okay, I'm just going to use variables for now. If you have log base a of x, y, this is going to be equal to log base a of x plus log base a of y, okay? Remember that when you multiply, normally you're going to get a number that is bigger. Or when you're multiplying, you're basically adding. So to remember this rule, simply remember that x times y is kind of like adding y x times. So you need to add, basically. And you're going to add each of the factors that you see with base a, okay? This is one property. Now we have another one that is this one. If you have log base a, once again, of x over y, now what you're going to do is the following. Log base a of x minus log base a of y, okay? This is another rule for division. Now, how can you memorize this one? Well, if you remember the one at the top, you know that division is the opposite of multiplication. So instead of adding, you're going to do the opposite, which is you're going to subtract. And that is how you can remember this rule. Now we have another one, which is this one. If you have log base anything, I'm going to go again with a, of x to the n power, this is the same as if you grabbed n and moved it to the front, so you did n times log base a of x, okay? If you know a bit of calculus, which is unlikely since you're learning logarithms, but if you know a bit of calculus, remember that derivatives, they have a power rule, which is basically bring the exponent to the front. This is exactly the same. You're gonna find if you have log of x to the some number, this is gonna be the same as if you grab n and moved it to the front to multiply log ax, okay? Now another rule that we have is this one. Log ab base a of b is going to be equal to, now this rule is very important for equations, because if you want to change a for any number that you want, you're going to do the following. You're going to say log b over log a. And now, see, I'm missing the base. Well, you can put in any number that you want. For now, I'm just going to say that this is x, okay? So you know that you can put any number. But basically, any logarithm that you have in this form, log AB, you can change its base by going log B and the base that you want over log A, and the base, it has to be the same one that in the top, of course, right? But this is how you can change the base of anything. So just to give you a quick example, if you have log base 8 of 64, you can do the following. You can say this is log base 3 of 64 over log base 3 of 8, okay? This equation is true. And this, of course, should also be 2, okay? These two logarithms dividing each other, they're going to be true. And now that I'm actually using this example, I'm going to use these rules in this problem. So, for instance, let me grab this one right here, the log base 3 of 64. If we have, I'm going to write it again, log 3 of 64, we know 64 is the same as if you had 8 squared, right? Now, let's use this rule. You see that we have x to the n, 8 squared. So this is the same as if you did 2 times log base 3 of 8, okay? Now, this equation is also true. Now, we know, for instance, that log 8 squared, now I'm going to write this again over here, log base 3 of 8 times 8. If we use this rule right there, well, we know this is simply going to be log base 3. Now you add, remember, you're multiplying. So you have log base 8 plus log base 3 of 8 and log base 3 of 8. Okay, and now you're adding two things that are equal, so you know this is also log 2 times log 3, 8, which is exactly what you got down here, okay? You can see that these rules, they are cohesive. And I didn't try this rule right there, but you can try it by yourself and you're gonna see that it is true, okay? So I hope you have learned something about logarithms. I'm gonna upload some videos doing a lot of equations, logarithmic equations. That is the best way in which you can memorize these rules. And well, they're going to be really useful. There are also some things that I want to show you, like this one. If you have a to the log base a of x, this is equal to x. This is like a typical rule that you're taught, but you have no clue why it is true. I also want to show you that, but that's for another video. So yeah, I hope you enjoyed this, and I really liked it. So yeah, see you in the following one. I hope you learned something, and bye.